there! Today we're going to be talking about special cases of factoring. In particular, we are going to look at the difference of squares and the perfect square trinomial. Keep in mind that all of these problems can be solved using the typical factoring algorithm that you would use for any factoring problem, as long as you're paying attention to what you're doing. However, you can save yourself much time if you recognize that each of these fits a particular form. Let's take a look at the difference of squares first, because that is quite a bit easier. This says that any binomial of the form a squared x squared minus b squared can be factored down into ax plus b, ax minus b. Very simple, yes. Let's see what that looks like in action. We start with the very straightforward case of x squared minus 16. Notice how 16 is a perfect square, and though there's no number in front of x squared, we assume that it is 1, and 1 is a perfect square. So setting this up, we're going to do x plus a number, x minus a number. What is that number? It's going to be the square root of 16. So we will have x plus 4, x minus 4. Yes, very good. If our next example, 25x squared minus 81, is more difficult, it is only marginally so. Let's start by taking a look at this 25 right here. This means that I'm going to set up my answer with a 5x plus a number, and then a 5x minus a number. Once again, to find out what that number is, I'm going to take the square root of 81, which will give me 9. Therefore, my final answer is 5x plus 9, 5x minus 9. And now on to our second special case, the perfect square trinomial. This says that any trinomial that fits the form of a squared x squared plus 2abx plus b squared factors down quite nicely into ax plus b times ax plus b, or more elegantly, ax plus b quantity squared. Notice how my first and my last term are both perfect squares. This does not guarantee that I have a perfect square trinomial. However, if I do notice that this is the case, I will always want to test whether or not I do have a PST to potentially save myself from a lot of extra work. Let's see what this looks like in action. Our first example here is x squared plus 6x plus 9. Notice the perfect square of 1 in front of x squared and the perfect square of 9 at the end. This means that when I'm trying to find a solution, I'm first going to attempt x plus 3 times x plus 3, because 1 times 1 is 1 and 3 times 3 is 9. I will test my outer and inner products to see if this is indeed the solution, and x times 3 is 3x. 3 times x is also 3x, and when I add those two things together, I get the 6x that I was looking for, which means that my final solution can be written as x plus 3 quantity squared. Oh yes, quite nice, very elegant indeed. Our final example is 16x squared minus 40x plus 25. Notice once more how our example is bookended by two perfect squares with the 16 and the 25. So to start my solution, I'm going to write down 4x and 4x in both of my parentheses. I would love to put plus 5 and plus 5, but notice how my b value is negative and my c is positive, so I'm going to put two minuses. I will do minus 5 and minus 5. Once again, use my outer and inner products to assess whether or not this is the solution. 4x times negative 5 is negative 20x. Negative 5 times 4x is also negative 20x, which combine to give me my negative 40x, exactly what I was looking for. So my final solution here is 4x minus 5 quantity squared. Very simple. So, you needn't remember these special cases. However, if you would like to save yourself some time, or if you're feeling, shall we say, a little bit saucy, then this will definitely help you accomplish your goals. Righto. Have a good day.